Good morning, everyone. I'm Srinivasa Mahendrakar, back again to introduce another distinguished speaker, Richard Seroter. Richard is a long-time Microsoft MVP, Pluralsight trainer, lead editor at InfoQ.com, a frequent public speaker, and author of multiple books. He is currently working as a senior director of product at Pivotal. He's a very popular blogger. Personally, I have been following his blog for more than 10 years now. He writes in-depth articles on technology, architecture, and design, especially in integration space. I really enjoyed reading his blogs. Today, Richard is going to talk about a topic, moving to cloud-native integrations. Ladies and gentlemen, please welcome Richard Seroter.
All right, so yeah, thanks for having me. We're going to talk about cloud-native integration, going to do a handful of demos, a bunch of them live. We'll see what happens. So, meet Stevyan. He likes to run. He obviously optimizes probably for speed, the right shoes, his aerodynamic hairstyle, his skin-tight clothing, so that's a mental picture for all of you. So, he optimizes for his own speed, which is great. The problem is, what happens if he's tethered to somebody who's not going super fast? Right? Like, does it make a big difference if he does all this work, if he's stuck with somebody who's dragging him down? Now, he might say, Richard, isn't it still worth it for me to do the best I can? And I would say, Stevyan, I'm speaking, don't interrupt me. But no, it doesn't really make a whole lot of sense to optimize yourself if something else part of the process is slowing you down. That's this whole idea of the theory of constraints. So this idea is that processes are limited to throughput by the constraint, the bottleneck. You can only go as fast as the bottleneck, right? If you've got this slow piece, it doesn't matter if you optimize before it, because then you're simply going to build up all this inventory because the bottleneck can't process it. And if you optimize after it, then I'm just going to starve that process because it'll never get the amount of work it actually needs. So this idea is that you've got to focus heavily on that constraint. What is slowing you down and optimizing that? So hopefully, in software, that this does not happen to you, right? This happens in software. You're stuck waiting for the QA team. You're stuck waiting for a deployment team. Hey, you're maybe even waiting for the integration team or some app dev team. And you're stuck like Cookie Monster, waiting for cookies. So ideally, integration, though, isn't the bottleneck. And this can be tough in a lot of organizations, because integration can be that thing that has a bunch of specialists, and you're worried about, this is a team that's going to queue up some work and prioritize things, but it can become something that actually slows everything else down if you're not careful. So what we're going to talk about is this idea of cloud-native integration and what cloud-native is, what it means, and making sure that teams are thinking about a more cloud-native approach to connecting systems. So we're going to do three things. We're going to talk a little bit about integration today using some exciting Gartner statistics. We're going to talk about what actually cloud-native means, what that definition is. And then I'm going to do a handful of demos and call out 6 principles for kind of considerations. What does cloud-native integration actually look like? So integration today. So Gartner shows a number of scenarios that they asked a bunch of leaders, like, what do you care about the most in integration? And right now, and they asked today, and what about 2 years from now? And today, what they care about the most is application-to-application integration. Number one, thing that matters the most. So we all have jobs. We will for the foreseeable future. Awesome. But if you look 2 years from now, the number one thing they're going to care about is cloud service integration. Now, obviously, the top one still matters, but it goes down. And if you look at even more, API connectivity actually has the biggest jump. So this is where things are going. This is where the leaders of these organizations think integration matters. And maybe that's not always reality, but this is their perception. Clearly, we want to at least keep that in mind. So at the same time, though, spending on integration platforms, it is going up as a whole, but it's really flat on middleware. So Gartner's numbers that show how much people are spending, it's actually really flat on people buying software and putting it in their data center. It's still a big number, but it's flat. It's not going to grow for a number of years. What is growing is iPaaS, like triple-digit growth every year. And they're starting from a smaller number, so of course they can grow faster. But you can't deny that API management, iPaaS, is where a lot of the new money is going in these spaces. It's not going to some of the existing systems. So those are blasting by everybody else, which is pretty interesting stuff. So what's really interesting, and this stat, if it's true, Gartner said it, so 75% of large companies think that they're going to be doing some sort of hybrid integration. And so that means you are not going to say, I'm going to bet on one system, one platform, and that is going to be it for everybody. Instead, they're assuming that you are going to combine a number of things from different vendors and keep it from burning up. Now, citizen integrators, everybody can develop now. If you have a heartbeat, you can build integrations, I guess, even the dog. So 50% of large companies, though, do want to incorporate some sort of citizen developer, citizen integrator. And we've seen that all week, haven't we? I mean, many of these apps we've seen in Flow and even in Logic apps, I do not have to be a specialist to build them. Now, that does not mean I don't need specialists. There's going to be hard integrations. There's going to be things I need to do that require someone with expertise. But many of those things, if I have to send something from a SharePoint list into a Slack channel, why does that go into an integration person's bucket? Like, that's something somebody should be able to bang out themselves. So what's cloud native? So if you do the search on Google, the first result for cloud native is a page on the Pivotal website. On Bing, it's number 3, which means I can't trust anything on Bing now. But nonetheless, cloud native is a thing. And it's the idea of really 4 kind of characteristics that come together: microservices, continuous delivery, containers, and DevOps. And all this comes together to the idea of how do I deliver software in a cloud-ready fashion. It does not mean it is running in the cloud. It is not about where, it's about how. Cloud native is how. How do I build software? How do I deliver systems? And I could do that in my own data center. I can do that in a co-location. I can do that in public cloud. It's a mindset, and it's kind of a technology set. But does not require public cloud. Really, the point is you're building for scale, you're building to assume constant change, and you're building to tolerate failure. If you're doing those things, you are building in a cloud-native fashion. And that is very much the antithesis to how a lot of systems are built today, and we'll talk about that in a moment. So, traditional enterprise versus cloud-native. Traditional enterprise, orgs are arranged by silos, and they have different competing priorities, right? Ops is prioritizing stability. That's how they get paid. Dev is prioritizing speed of delivery and all kinds of features, because that's how they get paid. QA, hey, if they find lots of bugs, somehow that's success. Project manager doesn't care if the product works, is it on time? Like, you have all these weird competing priorities in most organizations, which means no one's focused on what actually matters, which is the customer. And really, arguably, no one has done their job until the customer is using their software successfully. Every other success metric is irrelevant. In cloud native, balanced teams, meaning you've got all sorts of different skills in one team, and they're all focused on a shared objective. Traditional environment works on my machine, right? I'm developing on my machine. Things work great. I'm sorry, production's a tire fire. I can't help it. It's cool. But no, cloud native means everything is consistent. From my workstation to the cloud to all sorts of environments, I use automation. I use other ways to actually have very similar stamps of environments everywhere. In a traditional place, if you have a change, you actually follow an exception process. I mean, I'm sure if I asked some of you, is a change an exception, you would say yes. That is not how cloud-native companies think. Changes are treasured. You love the idea you have a change, because that means you're shipping new capabilities. You've done some experiments and you're updating code. Like, changes are awesome in a cloud-native world. Changes are terrifying, and you do them at 3 o'clock in the morning on a Saturday when you're in a traditional enterprise because they're risky. Cloud-native companies, it's boring. On a job interview, you should be asking developers to push to prod because you trust your pipeline that much. If you can't do that, you're not as completely far along as some of the cloud natives. Traditional enterprise security is the perimeter, right? You've got these crazy great firewalls that somehow block YouTube and Netflix and nefarious traffic. And then you also just kind of get a bunch of patches and you triage them, right? You can't deploy them all at once, patch Tuesday, and figure out where I deploy what. Cloud native, though, says everywhere security, encryption at rest, in transit, credential management, and then what Pivotal calls the 3 Rs, meaning you repair constantly. Means you're always at 100% patch level. You're repaving, meaning you're blowing away servers all the time. You don't have that jump box that's been alive for 3 years that no one's rebooted. You're blowing away servers constantly, so then, even yesterday, we just saw the news about that ransomware attack and more hacking. People can get into these accounts and stick there for a while because these environments never change. So this idea of cloud native is you're always changing credentials, you're rotating them, repaving environments. Traditional enterprise, you try to prevent mistakes. Your measure of success is mean time between failure. That is not the metric that matters. What matters is mean time to recovery. I assume failure in a cloud native world. Infrastructure will fail, clouds will fail, everything will fail. And I will build for that, and I will purposely introduce failure to find those points that I have to fix. Mean time to recovery. I don't care about mean time between failure anymore. Scaling is careful planning. You probably have meetings, workshops. How am I going to scale this from 1 server to 5? That's a big deal. In a cloud-native world, I am scaling all the time, and I'm actually scaling individual components up and down. You're not allowed to say you have auto-scale if you only scale up. I think I saw that in the Event Hub stuff. That doesn't count. You have to be able to scale down, or else it's not totally auto-scaling. Auto-inflate. You need auto-deflate, buddy. Software is a... Traditional, that's right. I got the mic, baby. Software is planned in bulk in a traditional enterprise. That's right, he's scalding down here. Traditional cloud native, though, I mean, you're delivering it in small batches. That's the word you should walk away with when you think of cloud native. Small batch discovery. I'm experimenting. I'm figuring things out. I'm shipping it, learning stuff, doing it again. I don't do big bulk releases. You have these single long-lived technology stacks. We're an IBM shop, or an Oracle shop, or a Microsoft shop. We use this technology for everything because we are going to milk every possible bit out of it. Versus cloud native say, look, different teams may use different tech. I'm going to be dynamic. I'm going to consume on-demand cloud services, even if they're on-prem, but they're cloud e-services. So which of those sounds like your company? And I'm not looking for a show of hands. That's fine. But you have to think about which feels like my integration practice. Am I a little bit hard to change? Do I do big batch releases? Do I have to scale my whole environment at one time? Or do I have a little more agility there? Am I a cloud native? So what does cloud native integration look like? This is a little different because cloud native apps, if you go to 12factor.net, those are principles for 12-factor apps, how people build actual web apps in a cloud native fashion. It's a good set of principles to follow. The same thing doesn't exist yet for cloud native data or security or integration, but these are some characteristics that I've thought of here. So as we think about today's integration, in many cases, you have teams of specialists delivering systems somewhat manually using these centralized platforms, single instance, typically an on-prem focus, although we're clearly trying to change that. And they're not really designed for elasticity, not crazy bursts. So how do we start to fix that? Well, we build spaceships. We're composable. We want to make sure that we're building composable systems, meaning, hey, loose coupling. We've all been talking about loose coupling for years. That's not new. But it's often easy to kind of sneak in coupling into our systems. Even with logic apps, you can accidentally sneak in some extra coupling that you can pull out. So how do we not do that? Sometimes moving to choreography, saying it's not just orchestrating services where I have a set of sequences I'm running, but I'm actually going to just use an event bus. I'm just going to use a service bus. I'm just going to drop in events and other people pick them up and do something with them. I'm not prescriptive about how it has to run. I'm going to try to push more logic to the endpoints. We're going back to dumb pipes and smart endpoints. Instead of having a bunch of intelligence in the bus that I have to maintain centrally, these teams, these kind of microservices, DevOps teams running their service, they can invest in logic in their endpoint. I don't have to just have all this intelligence in the middle tier. And then finally, targeted updates. I can fix individual components when I do it this way. I do not have to say, let's upgrade the entire integration at one time. I can upgrade individual pieces, which is what I'm going to show you. So what would happen if I use logic apps to start weaning people off an ETL process and I start doing more real-time processing? And then what would happen if I want to update one component in a specific way? So let's take a look at that. What are the odds I'll get 3 demos working today? All righty. So let's go ahead and open up my primary logic app. I'm going to see if I can make it a little smaller so you can't even read it at all. There we go. Let's go bigger. All right, so I've got my regular logic app here. It does a lot of crazy stuff. Let's go ahead and edit that. So what this thing does is receive a message from a queue, and none of this peak lock garbage. You got to feel alive. Read and delete. None of this safe stuff. So YOLO, man. I mean, read and delete. So I'm going to call a service I've got running in Azure App Service. So I've just built a Node.js REST service. I'm going to call an Azure function that just checks for fraud, because you can imagine as I do more machine learning, as I do more intelligence, I'm going to find out some models that look like fraud, and I can feed that back into a cache or something that I could look up on the fly for every message coming in. And I'm going to send that message back to the queue for processing. So what you've noticed here is I've not picked the actual inbound transport. I didn't pick to use HTTP or file or whatever, because that's even a form of coupling I may not want. I might want to use this for multiple different types of input, and it's not necessarily easy to do that in a logic app today, saying here's 6 inputs, all come to the same flow. Instead, I'm just going to pick it up from a queue. So how do I get it to the queue in the first place? So let's go ahead and enable this character. And let's go back. So in the first scenario, I'm just going to take in a file. And so this one is really straightforward. Let's enable it. Let's edit it. And so what this thing does is it pulls a file from OneDrive, because you're trying to upgrade your partners to use OneDrive, not FTP. And so they're going to drop a file. I'm going to parse it, because it's a JSON array. And then I'm going to dump each one of those back to that queue that the other logic app is listening on. So I've decoupled that a bit. All right, so that thing should be enabled. Fantastic. And so here is my OneDrive folder that I'm listening in on. Here is a batch file that I'm going to go ahead and drop in, just consisting of a few JSON bits. And let's go ahead and start up a little listener I have here. That thing's going to read from the queue that gets dumped out to by the major flow. Let's make sure it connects. Let's hear it for Wi-Fi. And then let's go ahead and drop that file in here. So here's that JSON file. Let's drop that into OneDrive. And because I'm impatient, I will go ahead and kick off the file and take one. Let's run that bad boy. Let you go ahead and read. And if I jump back to here, at some point soon I should actually see that what it did is it picked it up, it parsed it, it sent 3 individual files. So I would spin up 3 logic app instances, and yeah, there we go. So I went ahead and picked up the 3 files, and then my queue pulled it back off. So I've decoupled it, right? I'm trying to train them to think more real time, but even for now, I'll take a batch file. That's fine. But let's say I am ready to say, gosh, some of your processes can actually be sending in real time. Let's also use HTTP intake. And so in this case, I'm going to dump to that same queue, right, that the other main logic app is listening on, but in this case, I want to take in an HTTP request. Multiple ways, I'm decoupling, loose coupling, which is letting me then send this in. So let's go ahead and make sure that's running. It is. I have another app here that just pummels messages into my queue. That's a .NET Core app. I like to increase my risk by using lots of different languages. And so I'm sending in a bunch of messages. I'm getting a bunch of messages out. Things are happening. All right, so finally what I want to do, though, is actually I want to change that enrichment service, right? The one I call out to from the main app. I want to make a change to that. I just discovered some new feature. I want to do a small batch change. So I'm going to go into my service. And let's see, here's the enrich one. So here's the enrich service. And I want to add a new property, at least for this customer or something, whatever I want to do. And I'm going to go ahead and just add a new property, account standing, to their data record. So I've changed the service. So I've got that app service actually hooked up to GitHub. So when I check this into GitHub, it automatically gets deployed and then automatically gets consumed. So if I go to GitHub, I should see I've got a change here. All right, so let's go ahead and check that in. Commit to master, sync. It does its synchronization. And hopefully fairly soon here, what we would see is we'd actually see messages coming in pretty quickly, because again, this is getting updated real time. I'm going to start seeing, when I have that 100 supplier coming in, I'll see new properties with their account status. So I'm automatically adding that to the message, of course, very quickly as I keep talking about it until it happens. It's going to happen. I feel it. Yeah, it's thinking. That's what I like. There we go. So my account standing. So my real-time pipeline, I updated my pipeline in real time, right? I changed one component, and instantly it's taking effect. I didn't have to redeploy the whole logic app. I didn't have to go change everything. I could do a targeted update of one thing in my pipeline because I've decomposed it. Demo number 1, success. But wait, there's more. All right, so that's cool. But I've also got more always-on stuff when I'm doing cloud-native integration. I assume my systems are online more often. Events are always coming in. You are not allowed to take maintenance windows anymore. You cannot say Friday nights we're going to upgrade the environment, because your environment doesn't stop. Your company doesn't stop. People are using systems, submitting things. And so I have to think about, how do I make sure my systems can't take downtime? And that may mean different architectures or things like that. But in the cloud-native world, I've never gotten a notice from Microsoft saying service bus will be offline this weekend. Have fun with that. Like that's unacceptable. We won't say that. So why is that acceptable in your data center? So you think about different upgrade ways. Blue-green, different environments where maybe you roll it over from one to the other. Whatever your strategy might be, there's a number of patterns here. How do you make sure that you can make sure that system stays online at all times? And then simply handle failures smarter. When you do microservices, one of the challenges is that you've got more failure points, right? More things can fall apart. How do you prevent cascading failures? So you have to make sure you're able to catch these exceptions, handle them with default value, something that keeps you from having these big cascading failures. I also need more scale. This is a build-up GIF, so you're going to have to just watch it, live it. But I have unpredictable usage. And so all of a sudden, I'm just hit out of nowhere, right? And that's cloud native. I don't know when this load is coming. I have to be ready for things. Now, the old solution, when I would be an architect, back when I got paid to build things, I would actually just ask for the biggest honking machines I could get, right? Because I would never want to go back to IT and ask for more hardware. So I would have all these machines running at 1% utilization, but they were mine, and that was great. That is not how we should be building systems today. But you have to build for unpredictable scale, targeted scale, right? I might not have to scale everything. I don't need the whole thing to be huge. I need the thing that processes some sort of algorithm to be huge. And then other pieces are fine. They can run on a couple instances. So you're thinking about, how do I scale individual components a little better? Shared capacity is dangerous in a cloud-native world because I can still have runaway usage by one team consuming more resources. There's a reason that things like logic apps and others run on a grid, right? I've distributed my risk. I don't have people who can run out and take over the whole environment. So I have to think about, how do I not put everybody on the same thing? So it comes down to, again, the right tool, right job. You're going to have a mix of things, doing event-driven processing, ESB sort of things, notifications, IoT, all those sort of fun stuff. More self-service. If you were doing cloud native correctly, people are not opening up tickets to do everything, right? You're thinking about ad hoc integrators. How am I enabling people who might not be hardcore people like all the folks in this room, but they're people who do need to connect to endpoints? I need to give them some sort of diverse platforms. It will not always be one thing. You will not train 1,000 people in BizTalk at your company. If you have, then that is amazing, and you are a unicorn. Everybody else, you're going to have a team of specialists, and you have to figure out how to normalize that a bit. Now, again, we still need experts. I just have to embed them in teams, right? I can't assume that they're going to be just a center of excellence somewhere in the lofty ivory tower. They have to be everywhere, and you're seeing that even more with ops teams. You're embedding the ops people everywhere. So sometimes you can consider a simple facade. How do I make a slice of this big product to make it easier? Pivotal has this in-memory data grid called Gemfire, and we've carved off a slice of that to offer a caching product. And it's an opinionated view of Gemfire. It makes it easier for people to just use the one piece. So what if you could do that with BizTalk and say, here's this big, giant thing that's awesome. How do I give one slice of it to people who just want something simple? So what I'm going to show you is how to actually make BizTalk Server easy to use. That's a lofty statement right there. But when we go bigger, we go home here at Integrate 2017. So what are we going to do here? So what I want to show you is my BizTalk environment, assuming it's still online. Good. I'm still online. That's awesome. So nothing up my sleeve. There's nothing in my environment right now. I'll even refresh, because you don't trust me. We haven't been together that long. So let me go ahead and refresh. Nothing in here. I'm not making stuff up. OK, so what I have then is what I'm using is the Feature Pack APIs. So Feature Pack 1 added all these really awesome APIs to BizTalk, which lets you do all these sort of cool management things. So I mean, I can show, for example, using Postman, I can go ahead and make a request for all the receive ports in that environment and get back a nice JSON file. I can do the same thing with starting things and getting everything related to my app. That's really cool. So what would happen if I wanted to build a really nice little simple interface for people who wanted to do nothing but connect just 2 endpoints using BizTalk? They don't want to do schemas. They don't want to do maps. They don't want to configure receive ports. I just want a reliable delivery pipe. Can you give me that? Yes. Yes, you can. So what I did is actually build a Java app, because again, I like to make things hard for myself. And so what this Java app does is actually talk to that API and create everything you need to create a simple pipeline. So I'm creating receive ports, receive locations, send ports, things like that. So let's go ahead and start that thing up. And so I built a pretend product called BizTalk Pipes. I'll be selling this to Saravana when we get done. You know where to find me. And so what this thing does is let someone come in and say, well, I just want to create a new pipe, right? And I could have a HTTP input with 1 file output. In my case, I want to do HTTP input, and I want to send it to 2 files. So can you give me one of those? So sure. So let's go ahead and call this integrate. I'll go ahead and dump this to a file location on that machine. And so that's all I want. Just give me one of these. So I'll go ahead and submit. It calls the APIs. It actually goes ahead and creates that web receive location, creates the send ports, creates the subscriptions, all that fun stuff. And then it says, go ahead and send a message. All right, I will do what you tell me to, web page. I will come in here. I will do a post to that URL that it just gave me. I will do a raw message of application XML. And I will do something uncreative like that. And I will click send. And then something might have happened. You can't tell. So let's jump to BizTalk. What happened over here? So let's refresh my app. I've got 2 send ports. I've got a receive location listening in on a URL that's publicly internet addressable. I just hit it on the internet. So that must be real. I look on my file system, and there's my XML. So if I'm an end user, gosh, that's a heck of a lot simpler than going through the whole process. Now, again, that's somewhat contrived. You'd have to think of different ways you might do that. But realistically, why can't we put thin, nice to easy use facades on top of something like BizTalk and give it a really opinionated slice, right? This just released a 0.5% of what BizTalk does, and that might be fine. Because for some of your teams, you're just trying to get them to use the platform correctly. All right, demo number 2. Wait, there's more. All right, so you also have more endpoints. We want more stuff in your cloud native integration environment, right? If you're offering SharePoint, that is not edgy, right? You're not solving world problems by saying, hey, we just introduced a SharePoint adapter. You've got to open up, I have to send stuff to Slack, PagerDuty, talk to a Cassandra database, integrate with whatever. Like more endpoints, modern sources, right? That's what cloud native integration is going to be. Not everybody's using it, right? There's people here who want to process flat files into a legacy database or DB2. Awesome, right? That is still bread and butter. But you're going to have some innovative teams. You're going to have teams that really are trying to do some new stuff. Let them use the platforms you're giving them by introducing things that talk to modern endpoints. But you're also thinking about fast and slow streams. You're going to have things that send a ton of data in, and it makes a lot of sense to use certain platforms for that. And things that are doing more slow streams and endpoints that can handle just kind of trickle feed stuff, or even a function that responds to something that comes in twice a day. So you're going to have different types of data. You have to model that differently. There's new patterns. If you're trying to do CQRS or event sourcing or some of these other new event-driven patterns, you're going to have to think about what are the right tools for these, right? I'm not going to do event sourcing with BizTalk. I'm going to use something like Event Hubs, or I'm going to use something else that saves events and lets me assemble those into a virtual record. Whatever that would be, you have to use the right tool there. I mean, arguably at this point, especially after this conference, I can't see how we wouldn't say you should use Logic Apps anytime you're talking to a cloud endpoint if you're in a Microsoft environment. And if you're not in a Microsoft environment, you should really consider it. But if you're a BizTalk customer, you have no reason not to be using Logic Apps to talk to cloud. I don't think there's a lot of controversy there. If there is, you can yell at me later. Finally, the last characteristic. I think if you're going to do cloud native integration, you have to embrace automation like nobody's business. And we haven't necessarily done that. You need robots that do good things like do cereal for you. That means building via automation. You should be constructing every environment with scripts and automation. If you are lovingly handcrafting your BizTalk environments, you are an artisan, and we don't want you doing that anymore. Stop doing that. Everything should be stamped out as a consistent environment. Figure out ways to build these environments completely through automation. Same with test and deploy. Again, this should not be risky. It should not be a big deal when someone wants to do some deployments. I should be able to publish this stuff simply. I'm introducing automation to my environments. One measure of success is you can arguably say if you ever have to log into a server, you are not doing it right. Now, I just used a server there, so I guess I'm failing my own criteria. But ideally, you never have to RDP SSH into a server. That arguably means you're not doing it right because when you're functioning at scale, if you're repaving servers all the time, you might not even have the credentials for it, or you might not even want to know where the IP is. It doesn't matter. You should have good monitoring using BizTalk 360, using other tools. I don't know what servers are under Service Bus. I don't care. If I asked Dan to let me SSH into a server in Event Hubs, he would laugh at me and point and say, no, that's not going to happen. And then arguably everything in source control. Every configuration, every manifest, every component, that is step one of cloud native, is that none of this sits in the file system, none of this sits in your desktop. This sits in a version source control place where you can audit what's going on. So what I want to show you in the last demo was the idea of how do I automate Azure to some extent using a service broker. Now, service brokers were part of Cloud Foundry. Microsoft a couple weeks ago joined the Cloud Foundry Foundation. That's one of the things Pivotal sponsors, just like RabbitMQ and the Java Spring framework, things like that. But the service broker, it opened it up broader. So now Kubernetes uses the same service broker. What is a service broker? It's really a lightweight shim that coordinates the life cycle of a service, build, deploy, things like that, and also injects credentials into your environment. So as an end user, I don't have to know credentials anymore. I don't have to store them in web config. They're just in my environment. So multiple environments are now taking advantage of service brokers. So what if I just want to get Service Bus namespace or an Event Hub thing? As a dev, I don't want to log into a portal and do that. I just want you to give it to me. So what we're going to do is quickly show that off. Let's switch to this terminal. Make that a little bigger. So I'm using Cloud Foundry in this case, but just the idea that I can have a marketplace. And I added the Azure Service Broker, which Microsoft created. They have 10 people working on Cloud Foundry full time. And so they created a service broker that exposes things like Azure SQL databases, Event Hub, Service Bus, all these different components. Really nice of them to do that. I installed that into my environment just for fun. Now, this environment actually runs on Amazon, but worlds collide. Let's use everything everywhere. And so this broker lets me go ahead and deal with Redis cache and Postgres, MySQL, the artist formerly known as DocumentDB. I can do all these different things with the service broker now. And what this means is, as a dev, I don't have to use those systems directly, right? I don't have to actually go to the portal. But again, you may not trust me, so let's go back to the Azure portal real quick and show, if I look at my namespaces, what do I have right now? If I look at my resource groups, I have 3 resource groups. That's fine. What I want to be able to do, though, is actually consume a service bus instance from my app. So I have an application here, talks to the service bus, does all kinds of fun stuff. But because I'm using a service broker, I don't even have a connection string anywhere in here. Because what it does is actually can load the connection string from the environment. So me as a developer, I don't have to go get credentials, get keys, get any of that stuff. As a developer, I just want to automate it, build this stuff out. I don't care. So go ahead and let me jump into, here's my Pivotal Web Services environment. My app is crashed because right now it's not connected to the service bus. We need to fix that clearly. I want to connect to the service bus. So let's provision an instance of the service bus. So in this case, all I have to do is type in cf create service. And the broker that Microsoft built will take care of this for me. I'm going to give it a plan. You can have different plans for different usage. And I'll call it integrate SB. And I can point to a file that actually has some settings for me, and then immediately goes off and actually builds a namespace, adds a resource group, provisions my service bus environment, which is really nice of it. Great, so it's going ahead and doing that. So as a developer, again, I didn't have to jump to the portal. If I were connecting to Amazon SQS or Google Pub Sub or any sort of other system that a broker advertises, I just use it like this. I'm automating, again, the experience of integration. So let's go ahead and tie my application to that instance. So integrate service bus console is the name of my app. And the name of the thing I just built was integrate DB SB. And so what binding does says this app is allowed to use this instance, right? I just provisioned the service bus. Now this app's allowed to use it. What it means now is now the credentials are injected into my environment. So my app can actually use this successfully, hopefully. Once I do this, I can just restart my app, and it will go ahead and see those new credentials in the environment. Awesome. So let me just restart my application so that it actually gets those environment variables. While it does that, if we go back to the service bus console here, or the resource groups, let's refresh. Hey, now I have a new one, integrate generated. So the broker generated this resource group for me. It generated this new namespace. And now I've actually got what I need. Right? As a developer, I didn't have to jump to the portal. All that whole experience was automated for me. So that was really nice. So assuming my app restarted successfully, always risky. Let's go ahead to that application. View my app. This also used my intense design skills. And so as a developer now, I'm connected to the service bus. I'm able to create a queue, which it just did on first run. And then when I want to retrieve from the queue, it also pulls it. So as a developer, I didn't have to go to the portal to make this stuff happen. I'm able to just create an instance. I automated the whole life cycle of that, which is pretty wicked. 3 demos. There we go. I'd say, wait, there's more, but there's not. Automating the environment's huge for if I'm doing cloud native integration, right? People who want a BizTalk environment should not have to go ask for one. There should be images out there that they can stand up. I actually used the BizTalk image from the Azure Marketplace to build that second demo. That thing is really nice. It's got Visual Studio in there. It's got SQL in there. I did in 20 minutes what would have taken me a few hours to do if I hadn't used that. So that was really great. If you have not used that, you should. So that sort of environment's great. Build that for your internal environment. Make this stuff easier. Integration should not be so difficult. So what I'm arguing is you need to introduce cloud native integration if you actually want to deliver integration as a service at scale. And I would argue you have to, or you will be the constraint on these teams that are trying to move super fast. I mean, you can choose not to do that, but then you don't like money. And I think you like money. I think your organizations want to be good at software. Your organizations want to do a good job with software, and you don't want integration being in the way of that. Integration should be the enabler of your companies building some pretty awesome software. So that's it for me.